So again, I don't need you to just frantically copy everything down. I want you to kind of understand what I'm doing, why I'm doing it, and also look for mistakes. So if I screwed something up, let's figure out what it is and get it going. So this was our problem. We have a boat. We're going under a bridge. We have high tide, low tide. We come to it just after high tide, and we need to figure out when we can go back under the bridge. So our first step is understand what's going on. And for me, and this might be different for you, it's draw a picture time. So I have a bridge. I have low tide. That's at 8 a.m. I have high tide. That's at 2 p.m. And I have some distances, 40 feet, bless you, and 35 feet. And my boat is conveniently 37 feet tall. So it's going to fit at low tide. It's not going to fit at high tide. The question is, where is that cutoff? Where do I fit versus not fit? When do I transition? All right, so let's think about what my axes are. I have time and I have distance. And how are we defining distance here? Feet from what? From the bridge to the water. All right, that's going to be important. Because it looks like low tide is a longer distance, right? It's not a higher, it's not from mean sea level. It's from this bridge. Okay. So I have some points. There's my time. Those are my hours. These are my, here's 35 feet, here's 45. This is just a sketch, so I'm not that worried about scaling everything. I'm just trying to understand what's going on. All right, there's my high tide and low tide. There's low tide. There's high tide. And this I want to make sure when we know how we're defining distance. It looks like low tide is higher than high tide. But why is that? Because it's from the bridge to the water, right? So keep that in mind. So there we are. Now we show up here a little bit after high tide, unfortunately. So we know that we need to clear 37 feet. That's our boat. The question is, it's going to come back up. When does this point happen? Joe?
The boat says 37 meters. Is that just a typo?
That's just a typo that I can't fix on this one. All right, so that's a good point. Going back to the daily 2 problem. If it was 37 meters, how long do you need to spend solving this problem? 0 time, right? Because it's never going to fit. Good. All right, so let's read it again. Now I'm not that tricky. I'm just that sloppy. All right. So, nod your head if you understand the problem. Okay, good. Now we got to come up with the plan. How are we going to attack this thing? Well, we're going to write an equation, and I'm going to write a cosine equation. And the reason I'm going to write a cosine equation is because we have this nice, nifty way to deal with all the angles. Because I don't know, if I just use sine inverse, that it's going to give me this point. It might give me this point. It might give me a point over there. So I want to look at all of them, yeah.
Why did you start when tide at 6?
It should be at 8.
Or at 8?
Because, okay, good questions.
8 a.m.
I have it start at 8 a.m. I'm defining this at midnight, and then I'm going 2-hour increments. That's a good question. All right, so to get my equation, I'm going to need a vertical shift, I'm going to need the period, I'm going to need a horizontal shift, and I'm going to need the amplitude. Once I have my equation, I'm going to use our cosine to find when it's 37 feet. So I understand it, I have my plan, now we need to carry it out. And this is where it gets a little bit messy. All right, so there's my plan. Let's carry it out. So I'm going to redraw my sketch. I'm going to take a little bit more time here. There's my 2 points. And I have a sinusoidal axis. Now, it was key that it told me that it varied sinusoidally, right? Because what would be tempting to do between these 2 points? Just make it linear, right? But it doesn't work that way. The tides don't go straight down and then come straight back up in a nice, easy break. All right? So there's my sinusoidal axis. It's at 37.5 feet. It's halfway between what are my maximum and my minimum. So if I have my general cosine function, who can tell me which piece I now know about my equation? Which is now what? 37 and a half. All right. What's the next easiest piece to figure out? The amplitude. All right, so if I start at 37 and a half and I go up to 40, my amplitude is going to be 2.5. So there's my amplitude. All right. I forget what I got next. Oh, I figured out the period. I'm looking at B. So this is half a period. Right? Eventually I'm going to be back up here. That's a full cycle. So if half a period is 6 hours, how long is a full period? 12 hours. When I did this the first time, I just used 6. So be very careful at that point. All right. So I figure out my B value. B is pi over 6. I plug that in. And now I'm being a little bit more clear. I'm going to talk about my origin is midnight. I'm counting by hours. And I define D to be 8. Is this the only equation that works? No. It depends where I start, right? I could have talked about it starting here and inverting things, but for me it was nice to start here with my cosine curve. All right. This next piece is really key. Before you start plugging away, you know 2 points that should work for your equation. Check it. All right? So if x is 8, I should get out 40. If x is 14, what should I get out? 35. So plug it in. Before you go all the way through it, plug it in, make sure your equation's working. Turns out that this one does. And so we can keep going. All right? But I did check it. It's easy to make a small mistake like having this be a 6 and then everything's off. Okay? The other thing to think about is, even though this is 2 p.m., we have to talk about how we're counting here, and that is 14, right? It's 14 hours since midnight. All right. So there's my equation. I want it equal to 37. So I have the first part of my plan. I've got my equation. What do I need to do now? I need to solve it, right? So I start plugging through it, just like you did in algebra class. I divide by 2.5. And now to my inverse operation for cosine, I'm going to use as my arc cosine. So I apply it to both sides. Arc cosine of negative 0.2, arc cosine this. These are going to cancel. That's why I did it. And I'm going to be left with arc cosine on the left side, which we defined as plus or minus our cosine inverse plus 2 pi n equals this over here. And now I can keep going. I divide by pi over 6. And I add 8. So I've solved for x. But are we done? No, I got to think about what do I want to know. I want to know the first time past 2 p.m. that I have that value. So how do I go about that? What do I need to do? How do I get actual numbers? For what? N. I have this value. This integer here gives me all the rotations around the circle. Remember we talked about why we use arc cosine? I have my circle. There's a point. There's theta. There's negative theta. There's my plus or minus. And then if I want all the angles, all the coterminals, what do I have to add to this point to get another coterminal? 360 or in radians? 2 pi. Same thing with this one, right? I have to add multiples of 2 pi. There's my multiples of 2 pi. If I want a number, I just let n equal something. So I plug in some values of n. And is that going to be tedious or not tedious? Tedious. Good. So I'm looking for n so that x is bigger than 14, and it could be anywhere in there. I have plus or minus to look at, and then I have multiples of n. And so when we have a problem like this, my first thought is I'm going to use a spreadsheet. On Friday, my goal is to take us into a computer lab. There's a problem in the book you guys are going to work on that is really nice with a spreadsheet, really tedious when you're doing it by hand. So we go into a spreadsheet. We'll talk more about how to do that later. But we basically take this equation, put in different values of n, and look at the results. All right. There we go. So what I did is I let n go from negative 10 to 10. And then I looked at the positive cosine inverse values. I looked at the negative cosine inverse values. And then I had a check. I wanted to know that I actually, if I put this number into this, that I get 37 out. And I didn't get 37 out, but I got really close. Can anybody think of why I got really close? I should have got 37. But there's something I had to approximate. Or I chose to approximate. Pi. Right? When I plugged this into a spreadsheet, I used 3.14. And so I got close to 37, but I didn't exactly get it. But let's look at it. So I'm looking for a time value that is bigger than 14. So I look at the positive ones. Here's negative 108 hours. Well, that's not good. I can't time travel. Right? This is at least positive. So this is 11 in the morning. And then almost to midnight is when I hit it again. So that's no good. If I look here, this one, 16.61. So 16 and a half hours about after midnight, it's going to be at 37 feet again. So that value there is when I have my clearance. And if I wanted to convert that to an actual time, it's 4 p.m., 36 minutes, and 36 seconds. Now, keep this in mind too. And this is often a problem in engineering and just in life. We get these great answers to like, I could have gotten as many decimal places as I wanted. And I could have gotten down to the fraction of a second. Does that mean that you're going to plow your boat at this bridge at 4 p.m., 36 minutes, and 35 seconds? No. All right? It's a model. It's an interpretation of the real world. There's a lot of variability within it. So we have to be careful, again, about interpreting what does our answer mean in terms of significant digits. So that thing that you do in chemistry, right, actually has an application. Yes, Danielle?
Why is this in 616? Is this supposed to be 61? Or am I missing something?
I transposed it. Yes, so this is a wrong. It should be 1661. Thank you. So that's the number that I'm looking for.